Alright, so today we're going to talk about how to find the distance between 2 points and then the midpoints between 2 points. So your distance formula measures the distance between two given points. It's by this formula. D is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we're going to subtract our two x coordinates, square that result, subtract our two y coordinates, square that result, add it together, and then take our square root. Now, if it works out to be a perfect square root, life is easy. For all classes, you're just going to give that answer as your perfect square root. Now, if it's not, it depends on what your teacher is looking for. I know in my classes, I want you to simplify the square root as far as possible. I never want decimals for those answers, so make sure you talk to your particular teacher about what they're looking for. So again, that's for me. So we want to find the distance between two given points. A is 2, 3, B is 6, 11. So distance would equal the square root of our x's squared, so 6 minus 2 squared, plus our y's squared. 6 minus 2 is 4, so we'd have 4 squared. 11 minus 3 is 8, so we'd have 8 squared. And then 4 squared is 16, 8 squared is 64, so we have the square root of 80. Well, that's not a perfect square, so it requires you to simplify it. One method of simplifying square roots is to break it down to its factor tree, all its prime factors. So 8 and 10. 8 is 4 and 2, 4 is 2 and 2, and then the 10 is 2 and 5. So the square root of 80 has 4 2's and a 5. So since I circle all my pairs, any pair that I circle comes out, and if there's more than one pair that comes out, I multiply that pair together. I have a pair of 2's and another pair of 2's, so it'd be 2 times 2 is 4. So I have 4 on the outside and 5 on the inside. There are many other ways to simplify square roots, so however else you were taught, apply that as well. Well, either way, though, that's the answer I am looking for. Again, if your teacher allows you to have decimals, then you can go ahead and use your calculator to get a decimal. Now, that only happens if it's obviously not a perfect square root. If it's a perfect square root, you should be able to do that quite easily. Let's take a look at another one. So we have D equals, so we subtract our x's, so it'd be 3 minus a negative 5 squared plus negative 8 minus 7 squared. Well, we have minus negative, which becomes plus, so 3 plus 5 is 8 squared. Negative 8 minus 7, same sign, add them together, so this is negative 15 squared. Now notice I put that in parentheses. If you are squaring negative 15, anytime you square any negative number, it better come out to be positive. But if you put in your calculator without parentheses, your calculator will give you a negative answer back. And the reason why our calculator does PEMDAS correctly and sees the negative first and then, it sees the exponent first and then deals with the negative. But if you put the whole thing in parentheses, it will square the actual negative number. So keep that in mind. When I square 8, I get 64. When I square negative 15, I get positive 225. Those add together to be 289. And that is a perfect square root. It's 17. So if it's a whole number, great. If it's not, make sure you simplify. So go ahead and do this problem on your own. Plug in your x coordinates and your y coordinates. Subtract them properly. Remember, take care of your negatives. And then simplify your square root if it's not perfect. So pause the video while you work on that. Alright, you should have gotten the distance to be 9 square root of 2. So it was not a perfect square root. It should have been the square root of 162. You would break that down to be 4 3's and a 2. So that's your distance formula. The midpoint formula tells us how to find the point that is exactly halfway between two endpoints. That's what a midpoint actually is. So to find that, what we're going to do is we're going to add our x-coordinates together, divide that by 2. There's my x-coordinate in the midpoint. Add my y-coordinates together, divide that by 2. There's my y-coordinate in the midpoint. It's a very straightforward formula. So the midpoint for A and B, we would add our x's, 3 plus 9 over 2, and add our y's, negative 4 plus 6 over 2. This becomes 12 over 2, 2 over 2. So our midpoint M is 6, 1. Very straightforward. Not much to these kind of problems. You're just adding x together, dividing by 2, adding y's together, divided by 2. Please remember, it's a coordinate point, so there should be a comma in between. Let's take a look at another one. So we're going to add our x's together, negative 4 plus 1 over 2. Add our y's together, 7 plus negative 10 over 2. Negative 4 plus 1 is negative 3. 7 plus negative 10 is also negative 3. And when I do negative 3 divided by 2, I get a negative 1.5 for both my quarter points. Decimals, again, are always perfectly allowed. It should either be a 0.5 or a whole number, since we're dividing by 2 for each one of these cases. So again, just add x's, add y's, divide by 2. So we're going to find the midpoint between points j and k here. Be careful with how you work it out, and pause the video while you do that, so we'll verify the answer in a little bit. Alright, so your answer should be m is 8.5, comma negative 1.5. Alright, so that's it for this section. Next one is we're going to start talking about angles from here on out for the rest of this chapter. So I'll see you next time.